Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna starting a new playlist based on the lead code problem of the day. So if you are doing lead code problem of the day solution and you don't want to miss any consistency or you don't want to miss any day off, so do follow my playlist. So if you need any solutions or regarding explanation for the problem of the day, so do check it out my lead code problem of the day playlist. And if you like the video, subscribe to my channel and share it with friends. So let's get into this problem. So, so today problem of the day, let's put hard question. Okay, it's smallest in lexical order. So what is a lexical order? So lexical order is nothing but like arranging the numbers in an a lexical manner. So what is lexical manner? Suppose we have the numbers 100 to 100 and 2 and 101. So what is the lexical order of this number? So first we will check for the starting number which is the least one. So comparatively these three numbers, which is the smallest one? This one is the smallest one. So 100 comes 100, 101 comes before that two, right? So 100 comes 101 comes before two. And how do we arrange 100 and 101? Check for this number which is smaller. First one is 1, 1 same, 0, 0 same, then 0, 1. So which is smaller? This is smaller. So the order goes by this way 100, 101, and 2. So this is the lexical order. So mostly we will use this in terms of strings. So we take care about A, B, A, C. So which is the least lexical order? A, because A comes first, then B, then C. So specifically we use in the terms in the strings itself. So the same thing we are using in the numbers also. So we only take care of the starting numbers. So as one is smaller than two, so 100 and 101 comes before then two. So in that way, we will solve the elements. So, so what is the even? So we have given two numbers n and k, and we have to return the k like lexical smallest number in the range one and n. So so what I have to do is so we have to return if n is 13, n is 13, n is 13. So what are the numbers that are starts from? So the numbers that are will be starting from 1 to n, right? What are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we arrange this in a lexicographical order, what will the numbers comes first? 1, then comes 10 because as first digit is 1. So these all numbers are greater than 1. So we'll have these numbers at the back 10, 11, 12, 13. Then from 2 to 9. So what he asked, what is the k value? K value is equal to 2. So what does it mean? That to return the kth smallest number. So k equal to 1 and this is the k2. So what we have to return? We have to return 10, 10 as a number. So if you think of this solution, so what comes to your mind? So what we can do, we can create a vector of strings, right? And we can push back from 1 to nth element and we can sort it so that strings will be sorted in a lexicographical manner and we can return p of k minus 1. So we can do this approach, but just focus on the constraints. What is the constraint? What is the n value? N is less than or equal to 10 power 9. So these loops will give you the of n complexity, which means of 10 power 9. 10 power 8 equal to 1 second, as it is 10 power 9, which is greater than 1 second, which gives you TLE, time limit exceeded. So we had to think of a solution which is less than of n solution, which might be of n log n or some other solution. So you should reduce the time complexity as well as the space complexity, because we are iteration from 1 to 10 power 9, which gives 10 power 9 space, like, which is huge. So I had to reduce the time as well as the space. So, so what we can do is we can think of a solution in this way. So there can be a node one, one, two, right, three, and so on till 9. Zero is not included because so whatever be the number, it doesn't start with the zero, right? Because we need to generate, like, suppose smallest number from 1 to n. So only the 1 is included, 0 is excluded. So that's why we don't include 0 here. So it will be from 1 to n. For the 1, what we have 10, 11, and so on, 90, right? For 20, and so on, 20. In the again way, this is way 100, and so on, 109. So how is sequence going? So it is taking the same prefix as the previous parent. So let's say this is the parent node. This is the parent node. So what does the parent node consist of? Parent node consists of 1. So which is, so that is why the prefix of this child node is 10. 10 means the prefix of the child node is starting with 1. And we are iterating from 0 to 9. That is why. That is why. So all the prefixes of this child has 1, and that suffix goes from 0 to 9. So just take the another level. So here the level is, here the parent is 10. Sorry. Here the parent is 10. So the child has the prefix as the same as the parent, 10, 10, 10. And the last digit will append from 0 to 9. So that's how this prefix tree will go. So what we do is we'll calculate the steps. So how many number of steps that we needed. So suppose how do we know that k will lies on this particular step? So what we do is we'll check for those. Let's make one as the current, and this is next. What we will do is we'll check for whether our k will lies between these two. We'll check for whether our k will lies between these two numbers. Suppose if the number is 13, right? 13. So definitely the 13 will lies between 1 and 2. Graph 19, right? So k is equal to 2 and n is equal to 13. So what we do is we'll check for uh, what is the number of count of the numbers that is between from 1 and 2. So if the count is, let's say count is, what is the number of the count that is between from 1 and 2? So 1 plus, these are the 10 integers, 10. What will be the count? 11. And what is the k value? K value is 2. So as k is less than the count, which means that n, which means that k will fall under these two terms only. This is the current term, and this is the next term. So if this count is if this count is less than or equal to k, which means this k doesn't fall under this particular window. So it may be fall under some other window. It may be between three, maybe two or three. So then what we'll do? What we'll do is we'll increment the current. We'll increment the current, and what we need to decrease from the k? We'll decrease the steps. K minus steps. So what is the steps? The number of steps that falls under that particular window from 1 to 2. So in that way, we'll check. Suppose, what if that is falls under the same category? Suppose if that is falls under between 1 and 2. So what we will do is we'll check. So if let's take this for this, let's take for this example, and it's 30, and it's 13, right? So what we'll do, what we'll do is they will check until which level that goes. Suppose 13, 13, right? We'll check for steps equal to minimum of minimum of n plus 1 comma n2 minus n1. What is n2? It is the next term. What is n1? It is the current term. So how do we distinguish how many elements that are in the particular window? So suppose, see, we have 1, 10, 11, 12, 13, 14, and so on. So what we are doing is we are making n plus 1 as n is 13, n plus 1 is minimum of 14 comma 14 comma what is the max current value? 20, right? Yes, it is to next level is 20, because for this level it is until 10 to 19. For the next level it will be 20. So minimum of 14 comma 20 minus this is the n1 term minus 10. What is the minimum? 14. 14 minus 10, which is 4. So let's check for how many elements are between from until n in this level. 10, 11, 12, 13. 4 elements. So that is a 4. So that's what we are using to calculate the number of steps. So we get in these steps. So at each level, what we are doing is we'll calculate the number of steps. If number of steps is less than the capped value, we'll increment the current. We'll increment the current and reduce the number of steps k equal to k minus steps. Otherwise, what we're gonna do is otherwise if that is falls under the same particular step, what we are doing is this is the current, right? If this falls under the same category, what we are doing is we are multiplying k current is equal to current into 10. Why we are doing? Because it should follows this pre-order traversal. Like from 1 to we are going to 10. So it should be current minus 10. As we already visited 1, what we are doing is k equal to k minus 1, because our one element is visited. So it will be doing until k becomes 0, then we will get the answer from that variable. Suppose if that steps is less than kth value, what we're doing is we'll increment the current. We'll increment this current value. Yes. What we'll do is we'll increment the current value, and what we have to reduce from the k, the total number of steps that has to be has to be run will be subtracted from the k. So k minus is equal to steps. So that's how we're doing. So let's code it, guys. So you'll get to know everything clear on it. Let's get into it. So what we are doing is long. Why we are using long? Because there might be a number which is like around 10 power 9. So in order to eradicate or get rid of the overflow of the integer, we are using long. But at the end we'll use integer. We'll type cache into integer. Long. Let's make current equal to 1, right? Current is equal to 1. And we have to reduce this k minus 1. Why? Why we are doing? Because We are traversing from one. Why we are doing this? Because because we are we are traversing from one in order to, and traversing from one as it is from zeroth index. It is from zeroth index, but we are traversing from one. So in order to get zeroth index, we are subtracting one from it. K equal to k minus one. And while what we have to do is k greater than zero. Let's make more visible. Well, k greater than zero. What we need to do? Int steps is equal to count function. So this count function will get it will get the number of steps that will be needed. Okay, and if this steps is less than or is equal to k, which means k is in some other window. What we'll do? We simply make current as one. I mean, we'll increment current as one. Current is equal to current plus one. What we have to subtract from this k? K minus total number of steps that is need to be visited for that particular window size. Else, else, else what we need to do? Else, what does it mean? It falls under the same particular window, right? Else, current is equal to current into 10 and k equal to k minus 1, right? So why we are doing k current is equal to current 10? So for if the window falls under 1 and 2, then what is the number that comes after 1 is 10 because it is the lexical smallest unit. So we have to multiply by 10. As as, as 1 appears, what is the next number comes under? If that is falls under 1 and 2, then what is the number that comes after 1? 10. That is why we are multiplying the current value. Okay. In the end, let's just return. As we mentioned, current as long. So we have to make it as a typecast integer, return false. Okay, return current. So let's fill out how do we find this count, right? Should return main integer. What are the elements that is needed for this? We need n as well as the current, long current, as well as the next element, right? So so here let's take int, let's take long steps. Should return me the steps. Steps is equal to 0. Why? So while current less than or equal to n. So how do we are calculating from the steps? How do we calculate the steps? So I'll check for how many elements that are between 1 and 2. From 10 to 19, how many elements? Then for the next iteration from 100 to 200, how many elements? So that's how we check it. Suppose we take the example here. For the first from one and two, we have one step, and from as we use the same formula, minimum of n plus one, comma next minus current element. So why we are using, because to get the how many number elements that are present at the particular level. So here we have 1 and we have 5. So total will be 1 plus 4 is equal to 5. So total number of elements is 5. So that's how number of steps will be returned. So let's get into it. So current less than n. Steps plus equal to steps is equal to steps plus minimum of. What is the minimum of? to make even typecasting as any integer. We are making it also as long, 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 long. N first one, comma, minimum of n plus one, comma, the next term minus current number, right? Current number. That is the number of steps. And as we calculated for that particular level, what we are making is we are multiplying with the current number into 10, because for the next level 10 becomes 100. So it's 10, and also next also becomes 10, and the end will return int of steps. So that's how the steps function works, and it will get the steps here. But we have to pass the parameters. We have to pass the parameters int and long, long. What is the current? Current. See, we have to pass the n, current number, and also current plus one as next term. So it will get the total number of count. If the count is less than or k, what we do is we'll increment to the next counter, so that it will we will check for the if the number is present, kth number is present in that part, as the next window. And what we do is we'll subtract the steps from the previous window, or else what we'll do, will multiply with the current into 10, because there may be a case that is present in that particular window, and we'll get into that particular sublevel, maybe subtree. Then what will happen to the k? K will subtract 1 from the k, because it exited what particular parameter, so one number will be subtracted from k. So, and then the answer will be shown in the current value, because as the loop goes k greater than 0, this current will be adjusted based on the particular value of k. So just show to the kth value. Show it. Yes, done. So that's it for today's video, guys. If you like the video, do share it, do subscribe to my channel, share it to your friends. And if you had any queries, write it on the comment section. That's it for today, guys. Thank you. Bye bye. Stay tuned. See you tomorrow with new problem of the day. Bye bye.